the universal, oh sorry, it's still set theory. Talking about the universal complement and difference set. So let's first begin off talking about the universal set. So first off, there's nothing different that you're going to be doing in finding the universal set. It's more of a definition and a more of an idea in regards to certain problems. So the universal set is a set first and foremost. Okay, it's a set. It's you defined a set using set builder notation or vocabulary. You can do all that. Nothing new in terms of finding the universal set. However, the universal set is defined as the set for the set which includes all elements that pertain to the problem given. Now, on Thursday, we're gonna be working a lot more on Venn diagrams and how to draw them. But a Venn diagram here does a very good job in its most basic form. So um, it uses the letter capital U. Okay. So if I have this right here, so we would define this as set U. And this is the space, all of my elements are in this set. So in the problem, I'm saying I'm only caring about these values. Okay, so we can define a set just like we did on any one of our homework problems or any one of the topics that we've covered up until this point. We can define it just as such. But we close off the world. So, in reality, if we're talking about numbers, numbers can be um, um, we could talk about all of the real numbers would be every number, but maybe we're not interested in every real number. We're only interested in integers. So I can define my universal set as integers. And then within those integers, now we're going to start investigating problems. But of course, these can also be, we can define universal sets. As we say, we can define sets as anything. So if U equals Mr. Gutierrez, Ms. Kogut, Mr. Yi, Mr. Sheehan, or sorry, I didn't mean to say you. And Y is every set needs to be a subset of U. Okay, every set is therefore a subset of U. What could the set U B. So what are possibilities? So there's many possibilities of what we can define the set U to be, and they could be correct. So here I have I've defined a set, and this set is a subset of U. I didn't mean to put quotation marks there. I meant to put the capitalization. What would be the universal set we're probably looking at? So one of the subsets I have is Mr. Gutierrez, Ms. Kogut, Mr. Yi, Mr. Xian. What is the universal set, or what could be a universal set? Who? So the elements are Gutierrez, Kogut, Yi, Xian. These elements are a subset of what? Of who? Who could we be interested in studying? Does anybody know at least two of these people beyond me? So, are just as a reference. Okay, you know Miss Kogan. What does she do? Math. She's a math teacher. Okay, Mr. Yi. Who is that? I don't know, Mr. Yi. If you had to take a guess. Math teacher. Math teacher. And Mr. Xian? It's another math teacher. Another math teacher. So what could be the universal set? Mm-hmm. Math teachers. And actually, there's no quotation mark. At BCLA. That could be correct. Or we could just say the universal set could be teachers at BCLA. My point here is that both could be you. So there's no right or wrong if I ask the question this way. What is the common trait? So in other words, the set here are just by definition. If I give you a set and I ask you for the universal set, you should just understand that this set has to be a subset of the universal set. All right. And so we can define it, the math teachers at BCLA. Now, if I listed out all the math teachers at BCLA, the four elements, the four teachers I listed would be amongst those teachers, those math teachers. If I listed all of the teachers at BCLA, Mr. Gutierrez, Ms. Kogut, Mr. Yi, Mr. Xian would also be would be elements of all teachers at BCLA. So when we talk about the universal set, we're just saying, okay, we're going to be, sometimes in the problems I'm going to give you today, the main problems I'm going to give you today, I'm going to define what the universal set is. But we can talk about contextually. We can talk about people or our numbers, where I say, okay, here are some of the elements that are in the universal set. So therefore, that is a set of itself in itself. So what could be the universal set? And you would explain that to me. These are all, you could be the math teachers of BCLA because Mr. Gutierrez, Ms. Kogut, Mr. Yi, and Mr. Xian are some of the math teachers at BCLA. They're part of the teachers at BCLA. So that's what we define as the universal set. So I just want to make sure we have that notation. Within a given problem, all sets, or every set is a set of the universal set. The complement set The complement set is the set that includes all elements not in the specified set. All units not. So the notation, we can use A, C, a little c, and the one that we'll use more often, A prime. So in other words, this right here refers to the set of elements not in set A. Now, for the most part, we're going to use this one right here. We're going to use the prime notation one, but that C is another way of writing it as well. We're going to use this one right here for your homework. That's what you'll see. You'll see the prime symbol, all right? Complement of A, every one of those is okay to use. So let's say we have a universal set, okay, that includes everything. This would be set A. Okay, that's set A. And set A prime sometimes we can do this. Would be everything that is in the universal set but not in A. So U is everything. I also want to note that U is therefore equal to A union A prime. So if we combine the two sets of what is in A and what is not in A, you get everything that you're interested in. So if I were to combine these two sets, the purple and the blue, you would have the universal set. So I want you to note, this is always true, that the union of the two sets would be everything that you're interested in that universal problem. So that is the universal set is the set that includes the set itself and the complement. So let's do an example. Let's define U, okay, as the set A, B, C, and D, and we'll define A as A and B, and we'll define B as B and C, okay? Let's find A prime. So if A is the elements A and B, what would A prime be? What would be the complement to A?
Would it be A and B?
Well, A and B is set A.
Would it be B and C?
So let me rephrase the complement part. A is the set A and B. The complement is everything else that's not in A and B from the universal set. So look at the universal set.
So C and D?
It would be C and D because C and D are not in A. Something to note as well, A is defined, and we can say A is defined as X such that X is in the universal set, or A prime, sorry, and X is not in A. So I could have written it like this. I could have written A prime as that. A prime or everything that is in the universal set, but it's not. That's the symbol for an element, but crossing it out means not an element of A. Let's see if you feel better on that now. Find the complement of B. Can I get somebody else that didn't answer this one? I want somebody else. That
Is it A and D?
it is A and D. Correct. Because A and D are not in B. They are part of the universal set. I'm looking at everything in the universal set that is not in B. And B and C are, so I just cross those out. So if I look at U equals A, B, C, D, and I know B is C and D, or B and C, sorry, then I'm going to cross out the B and C, and what I'm left with is my complement. Now we can add in other ones as well. We can combine. We can use some of the stuff that we've learned in our previous class. For example, find A union B prime. Find a complement of A union B. Now, when doing these type of problems, it is helpful to first define the set of unions and complements. So what we could do that would be helpful, let's first find A complement B. What is A complement B? Or sorry, union. What is A union B? So from the previous homework, everybody should now feel comfortable doing this. You spent 2 days on it, Thursday, Friday. What is A union B?
ABC.
ABC. Very good. So A, the union B prime, is therefore
ABC.
no. That's A union B. The complement, meaning that it can't include anything. By definition, the complement does not include anything inside the given set, inside the specified set. So we know 100% that A, B, and C are not in my solution. A, B, and C are not in my solution for the complement because A, B, and C are in my set. Once again, A, B, and C cannot be in my solution. They cannot be in my answer. A, B, and C cannot be in my answer because we're saying everything that is not in that set. Not. Yes, there we go, Isis. It is just D. Because D is the only thing left over from the universal set. Remember, the key here is we always have to look back to the universal set in all of these problems. All right, it is very important to note that for all of these problems, you always have to refer back to U. Okay. I have a little bit of space here. D, find A intersection B. I'll do it on the next page. Find A intersection B prime. The complement of A intersect B. Okay. Once again, it is helpful to first find A intersection B, which is not my answer to my problem.
That would be B.
That would be B. That's the only thing that is in both sets. That is in set A and in set B. So now A intersection B complement
A, C, D.
would be everything else A, C, and D. Very good. Because B is in the set A intersect B, and the complement is everything that is not. Do you think the responses came a little bit more fluid towards the end? So in your homework, that basically covers what is in your homework for 3.5. So that's what's in your homework 3.5. 3.6 is going to be on the next piece. So we have this idea of the complement. Now the same thing holds true. We are still talking about the universal set. However, we're just going to focus on the relationships between we'll talk, like, I don't want to do too much of the Venn diagram drawing. It does help, but I don't want to pull your focus because that's where I'm going to put the focus on in Wednesday. On Thursday. So I just want to point that out. All right, let's continue. So all of that was homework 3.5. Now, we're going to cover homework 3.6. And now the last part that we're going to talk about is the difference set. The difference set is a relationship set between two or more sets such that the elements are in one set but not in the other. So now there's two different ways to write this. The most common way is A minus B. It's kind of this difference, right? This is the set of elements in A that are not in B. The set of elements that are in A that are not in B. We could also write this as a backslash B. These are the two common ways. This is the other notation. This is of writing it. So you can write it A minus B or A backslash B. Both of these refer to the difference. They are in A, so that means our answer can only, so it's kind of like A is my universal set. And so therefore, A prime is the same thing as the universal set and minus A. That's the definition of A prime now. So we can define A prime, we can define the complement as the difference between the universal set and the set A. So A prime is defined as just everything that's in the set, the main set, the universal set, minus A. You can write it either way. But the purpose of the different sets is that we're going to look at two defined sets, okay? But you can basically, it's the same thing. You're just looking at your answer cannot include anything on the right set, on the minus set, on the different set part. All right, your set cannot include those, and it would include everything in the other set. So basically, when we're talking about these complements, it is like the complement, but the only problem here is that A is everything in A is in B, is in U, but that doesn't necessarily have to be a part of the second one. In other words, these two sets do not have to be the same ones, or do not have to both be one inside the other. So let's look at an example. Set A is defined as A, B, C, and D. And set B is defined as 1, 2, C, and D. Now I want you to notice the difference between this problem and the last problem. In the last problem, everything in B had to be in the other set. So now these two sets are not proper sets. One set is not a subset of the other. So that's the difference. In a universal set, we had to deal with subsets. But now I don't have to deal with subsets. In this problem right here, I actually have one set that is all letters and the other set that is both numbers and letters. However, there is some unisection. So as in terms of review, or well, let's find in this example A. Let's find A minus B. So can someone put this into words? Can someone put this set in words? A minus B is the elements.
Set of elements in A that are not in B.
All right. So A minus B would therefore be what? What are the elements that are in A that are not in B?
A and B.
A and B. A and B are in set A, but are not in set B. So C and D are therefore not, are not in my different set because they are in both sets. Another way of writing this, I want to point out that another way of writing A minus B is this X such that X is an element of A, but X is not an element of A intersect B. For those of you who like set builder notation, it is an A, but it doesn't include what's in both. It's an A and not in both. So what is an A but not in both? Let's try another example. Find the difference between B and A.
So A has A and B and B has 1 and 2.
Okay, so therefore, so what is in B that is not in A?
1 and 2.
1 and 2. Now, if you're having trouble thinking about this, one of the ways to do it is you first write what would it be is 1, 2, C, and D, where A is A, B, C, and D. So when you now want to cancel what's the C is in both and the D is in both, and therefore my answer for A, the difference between B and A is 1, 2, but the difference between A and B would have been A and B like we found on the previous problem. Okay. define U as A, B, C, D, E, 1, 2, 3, 4, and 5. Find the difference of B and A complement. The complement to B minus A. What would I get? Correct. Everything else, everything that's not 1 and 2. So I would include everything but 1. Well, remember, it actually does include C, um, the other one. So we're looking at what's not in a, so everything that's not 1 and 2. So the only things that I have to define for here is not 1 and not 2. So my set would be A, B, C, D, E, 3, 4, and 5. So I would look at my universal set and cancel everything else that is not, or cancel everything that is in the set that I'm trying to find the complement to, which is just 1 and 2. We'll get some other types of problems with these ones in tomorrow, but that's as much as I think one of you feel comfortable covering today. It was quite a bit of material, quite a bit of examples. Remember, your first homework, your first half of the first homework, the homework from tonight, which I also said due as Thursday, is only on the universal and the complement. So it does not include any differences. So you will not see the minus, you will not see the backslash. Okay, remember, the minus and backslash are the same thing, but we have to be comfortable using both of them. The homework assigned from tomorrow, 3.6, is a homework that includes the difference. It'll probably include some from tonight's homework as well. It'll include complements and universal sets as well. It'll include unions. Tonight's also includes unions and intersections. So we're trying to combine everything little by little. And with that, that's what I have for you today.